Imagine you're diving off the coast of Japan. You're about 300 meters below the surface, and the water around you is cold, dark, and almost completely silent. Visibility is maybe a few meters. Your flashlight cuts through the dark and hits the seafloor. And then, at the edge of the beam, something moves. At first, you think it's wreckage, maybe a piece of debris from a ship, or a tangle of thick cables that somehow drifted down here. It's far too large to be an animal, but then it takes a step, and then another. And slowly, as your light catches more of it, you start counting legs. 1, 2, 4, 8, 10, each one longer than you are tall. The thing spans wider than a car. Its shell is covered in what looks like a living garden, sponges and anemones growing directly out of its body. It doesn't seem to notice you. It just keeps walking, slow and deliberate, like it has been doing this for a very, very long time. You've just found the Japanese spider crab, and if you think the size is the strange part, you haven't heard anything yet, because the Japanese spider crab isn't just the largest crab on Earth. It isn't just the largest crustacean. It is the largest arthropod alive on this planet. And an arthropod, just to be clear, is any animal with an exoskeleton and jointed legs. That category includes every crab species, every spider, every insect, every lobster, every scorpion, every shrimp, every single one of them, across every species alive today. The Japanese spider crab is bigger than all of them. A fully grown adult can reach a leg span of up to 3.7 meters. That is roughly 12 feet from the tip of one outstretched leg to the tip of the opposite one. Their body alone, just the central shell called the carapace, can be the size of a basketball. They weigh up to 19 kilograms, which is more than most dogs, and they keep growing their entire lives. But here's what makes the size genuinely strange. The body is small. Compared to those legs, the central carapace is almost modest. Most large crabs look proportional, their legs scaled roughly to their shell. Not this one. The Japanese spider crab looks like two completely different animals got merged together somewhere in evolution. A small crab body, and then these impossibly long, thin, angular legs extending outward, like something that was designed by someone who made a serious error halfway through. It looks less like a crab and more like a deep-sea spider that got lost and never found its way back to land. Which is, of course, exactly why it has the name it does. So why does it look like this? Why the legs? Why the size? And why does almost every other fact about this animal break the rules we thought we understood? Most people who encounter the Japanese spider crab for the first time assume the story begins and ends with, "It's really big." They process it as a novelty, a record breaker, something to stare at in an aquarium photo and then move on from. But the size is almost the least interesting thing about it, because once you start pulling on the thread of how this animal actually lives, what it does, how long it lives, and what it has survived, you end up somewhere that makes the size feel like the most normal part of the whole situation. Part of the answer starts with where it lives. Japanese spider crabs are found almost exclusively off the Pacific coast of Japan, in water ranging from around 50 meters deep all the way down to 600 meters. And depth does something to evolution that shallow water simply cannot replicate. Cold, deep water holds significantly more dissolved oxygen than warm, shallow water. And for cold-blooded animals that absorb oxygen directly from the water around them, more oxygen in the environment means the biological ceiling on body size gets pushed dramatically higher. This is the same principle behind polar gigantism, the phenomenon that turns ordinary sea spiders into 2-foot-wide monsters in Antarctic waters, or ordinary squid into the colossal squid. Cold water and deep pressure are, over millions of years, a recipe for giants. But the Japanese spider crab isn't just a product of its environment, it's a product of time. Specifically, an almost incomprehensible amount of it. The lineage of the Japanese spider crab stretches back over 100 million years. For context, that means spider crab ancestors were crawling across the seafloor while Tyrannosaurus rex was still alive above the surface. They survived the extinction event that ended the dinosaurs. They survived every major mass extinction of the last 65 million years. They have been sitting in the cold, deep water off Japan, in roughly the same form, for longer than most animal families have existed at all. And over those millions of years, isolated in those cold Pacific depths, evolution had an extraordinarily long runway to keep refining this animal. Longer legs for stability on the uneven sea floor, larger body for storing energy in an environment where food can be genuinely scarce, slower metabolism to conserve everything the animal takes in, greater size to reduce the number of predators willing to attempt an attack. Generation by generation, across geological timescales, the spider crab became exactly what it is today. And what it is today is something that doesn't follow most of the rules we use to understand crabs. It breaks them, one after another, in ways that keep surprising even the researchers who study it most closely. Start with the camouflage, because nothing about it is normal. Most crabs have some version of a hard shell that blends passively with their surroundings. The Japanese spider crab does something far more active. It decorates itself. It physically picks up objects from the seafloor using its claws, sponges, anemones, algae, pieces of coral, sea urchins, sometimes even small living organisms, and attaches them directly to its shell using tiny hook-like structures on its exoskeleton called setae. The organisms it attaches don't die. They continue living on the crab's body, growing and changing over time, creating a living, shifting camouflage that updates itself as the crab moves through different environments. This behavior is called decorating, and the Japanese spider crab is one of the most sophisticated practitioners of it in the ocean. But what makes it genuinely remarkable is that it isn't random. Research has shown that these crabs appear to select decorating materials based on what matches their local surroundings, move them to a different environment, and they will rearrange their decorations to match the new setting. This implies a level of environmental awareness, of active perception and decision-making that most people simply don't expect from a crab. We tend to think of crustaceans as relatively simple, reactive animals. The Japanese spider crab keeps quietly suggesting otherwise. And this behavior matters most during molting. Like all crustaceans, the Japanese spider crab periodically sheds its shell in order to grow. The new shell underneath is soft and vulnerable for a period after molting, sometimes days. For most crabs, this means hiding, but something as large as an adult Japanese spider crab cannot effectively hide on an open seafloor, so instead, it becomes invisible in plain sight. Its decoration makes it look like a piece of the reef, a cluster of sponge, a section of rocky substrate. Predators that rely on visual detection simply don't see it. Now here is the fact about this animal that tends to stop people completely when they hear it for the first time. The Japanese spider crab may live for up to 100 years. 100 years for a crab. Most crab species live somewhere between 3 and 5 years. Even large, long-lived species like the red king crab typically reach around 30 years at the very outside. The Japanese spider crab potentially lives as long as a human being. The reason comes back to that cold, deep water and the effect it has on metabolism. In the cold, every biological process slows. Cells divide less frequently. Tissues degrade more slowly. The chemical reactions that drive aging happen at a fraction of the pace they would at warmer temperatures. This is why the Greenland shark, which also lives in cold, deep water, has a confirmed lifespan of over 400 years, the longest of any vertebrate on Earth. The Japanese spider crab operates on a similar principle. Its entire biology is running in slow motion, and the payoff is an animal that just keeps going. But what this also means is that the largest individuals you can find in the wild aren't young animals at their physical peak. They are ancient. The record-holding specimen, with its 3.7-meter leg span, was almost certainly an animal that had been alive since the early 1900s. It had been walking the same stretch of Pacific seafloor for a century. It had outlived every human being alive today when it was born. It had no concept of either world war. It just kept walking, kept growing, kept attaching sponges to its shell, one slow, patient century at a time. The way this animal moves deserves its own attention, because it doesn't move the way anything that size should be able to. Those legs look impossibly fragile. They are long and thin and jointed, and you would be forgiven for assuming they must be delicate, prone to breaking, barely adequate for supporting the animal's weight. But they are far stronger and more precise than they appear. Each leg operates with a kind of independent coordination, feeling out the terrain, adjusting grip and pressure, navigating uneven seafloor with a slow, deliberate accuracy that is genuinely unsettling to watch. The whole animal moves like 10 separate creatures that have agreed, for now, to go in the same direction. The claws, while smaller relative to the leg span than you might expect, are deceptively powerful. Japanese spider crabs are predators and scavengers. They crack open mollusks. They tear apart soft-bodied prey. They pick through whatever organic material drifts down from the water column above, and they are patient enough to wait a long time for it. Fishermen who handle them without care have come away with serious injuries. For something that looks so spindly and architectural, it is not a gentle animal. Once a year, something happens that doesn't fit the image of a solitary deep-sea creature at all. During spawning season, Japanese spider crabs migrate upward. They leave their deep habitats and move into shallower water, sometimes as shallow as 50 meters. And they gather, large numbers of them converging in the same areas, in a coordinated seasonal migration that researchers are still working to fully understand. The warmer, shallower water is better for egg development, which is part of the reason. Females carry their fertilized eggs attached to their abdominal appendages, sometimes carrying thousands of eggs at a time, and the slightly warmer temperature helps those eggs develop successfully. But the coordination of the migration itself is the puzzle. These are animals that spend most of their lives alone in cold, dark water, with limited sensory input and no obvious means of communication. How do they know when to go? How do they find the same gathering areas year after year? What is the internal signal that tells a solitary deep-sea crab it's time to climb toward the light? We don't fully know. The Japanese spider crab, even in its most studied behaviors, keeps holding on to its mysteries. Here is where this story takes a turn that's harder to sit with. This animal has existed for over 100 million years. It has survived every catastrophe this planet has thrown at life over that entire span. The meteor impact, the ice ages, the volcanic periods, the mass extinction events that wiped out the majority of species on Earth at least 5 separate times. Through all of it, the Japanese spider crab kept going, kept walking, kept growing, kept living its slow, century-long life in the cold, dark water off Japan. And then, in the last 100 years, humans very nearly fished it out of existence. Japanese spider crabs are considered a delicacy. A single large specimen can sell for thousands of dollars. For decades, they were harvested with almost no regulation, pulled from the water in the same spawning aggregations, where they gather most densely, at the exact moment when they are most concentrated and most vulnerable. The numbers dropped sharply. An animal that had survived 100 million years of geological catastrophe was running out of room to survive a few decades of commercial fishing. Japan has since introduced seasonal bans, prohibiting harvesting during spawning season when the crabs gather in shallow water. The restrictions have helped slow the decline, but recovery is extraordinarily slow for an animal that takes years to reach sexual maturity and potentially decades to reach full size. You cannot replenish a century-old crab in 5 years. The biology simply doesn't allow it. Every large ancient specimen that was pulled out of the water and sold is one that took 100 years to grow and cannot be replaced on any timeline that matters to the fishing industry. The population is still under pressure, and the full long-term picture remains uncertain. There's something worth pausing on at the end of all this. The Japanese spider crab is not a flashy animal. It doesn't have the terrifying teeth of an anglerfish or the explosive speed of a mantis shrimp. It doesn't glow in the dark or spray venom or hunt in coordinated packs. It just walks, slowly. Across the same cold, dark seafloor, it has been walking for 100 million years. It grows its garden of sponges and anemones. It cracks open a mollusk. It lives for a century and then, presumably, it dies. And something else picks it apart on the seafloor. But in that quiet, unhurried existence is something genuinely extraordinary. An animal so perfectly adapted to its environment that evolution essentially stopped changing it. A creature that has seen more of this planet's history than almost anything else alive. Something that looks so alien, so architecturally impossible, that the first instinct when you see one is to assume it can't be real. Right now, somewhere in the cold water off Japan, one of them is walking. It has been walking since before your grandparents were born. Sponges are growing on its shell. Its 10 legs are moving with that slow, independent precision across the seafloor. It has no awareness of us, no concept of what we are or what we've done, and it doesn't need one. It was here long before us. Whether it's still here long after us depends entirely on what we decide to do next. If this kind of deep-sea strangeness is your thing, check out the video on polar gigantism right here. The things evolution does when you freeze the ocean are even more unhinged than you'd expect.